Hello, everyone, and welcome. Thank you all for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful for your commentary and remain, please, professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link to our YouTube channel in the chat. I'll also be sharing some links to the Reactor Mira page and the link to our survey so we could know your feedback. Which brings us to our session today. This session will run for approximately 1 hour with time for questions throughout. Our speaker today is Sam Bronsky. He's a regional cloud advocate. I'm now going to pass this along to Sam.
Great. Hello, everybody. I am Sam Bronsky. I'm a regional cloud advocate here at Microsoft. My job is to help empower all of you to create and build awesome things with Microsoft technology. So what we've been building this month has been a SignalR web canvas. Where we're going to end up at the end of this stream is with this, mostly focusing on the right side. I'll talk about the left side later. But this is a series of pixels where we can actually go and draw whatever we want. I've drawn a smiley face, and this is using SignalR. So instead of updating your state inside of your web app, we're actually sending updates up to a server written in ASP to everybody that is looking at this page, which means we can actually have like a distributed way of drawing on this web canvas. So that's sort of how this works, is we have something where people can add their pictures to this and start drawing things. So that's sort of where we're going to kind of try to finish up. We've already built the basic website. We kind of explored SignalR. Both of those sessions are on the Microsoft Reactor YouTube channel if you want to check those out. This is going to be kind of wrapping up sort of the basic implementation of all of this. We're definitely not going to have this production ready by any means by the end of this, but we are going to have some cool working demo that kind of shows off this. So the way this works is you can select a color on top. There's a few different colors here. These are customizable, so I've just added 6. We can add more. It's just an enumerable list. And then as you click each of these buttons, they're just buttons behind the scene. That actually sends a update up to SignalR, which will then send that update back to our website. So we can actually start drawing things. I don't really know what I'm drawing exactly, but you kind of get the idea. It's just an interactive pixel canvas, so you can start throwing different things at that. Apologies if the screen is a little bit weird, just because of the size of some of the delimiters, the lines between pixels. It might appear a little bit weird for you if you are viewing this on certain devices. I haven't been able to figure out how to fix that, so apologies. But yeah, this is what we're building. So let's go and kind of check everything out. This is sort of my finished project, just so I kind of know it works. I've been learning SignalR and Blazor as part of this. Blazor is a way for you to build web apps using .NET and C#. So instead of writing it in TypeScript or JavaScript, you can write it in C#, and that's that. So that's what we've been doing, and this is sort of what we've built. You can see it's kind of broken over on the left-hand side. This is a caching issue that I have run into. We will try to reproduce this during the demo, but just in case we don't, the way I've gotten around a caching issue where CSS and HTML updates haven't been visible is by using an in-private browser. And that actually gets the correct style sheets into our browser. Otherwise, it's saving an old version. There are other ways you can add versioning and things to your style sheet, but this seemed quicker. So that's what I've been doing. Another thing, we don't store state. So by closing that window, I have deleted my work. It also means that if you join late, you won't get the existing drawing on the canvas. That's a problem we'll need to solve at a different point, because I don't really know how I want to solve that yet. There's probably a database solution somewhere in that, but I haven't figured that out yet. So this is our demo project. So I'm going to just move this over here and kind of out of the way. And let's go and look at where we are right now. So that was where we're going. This is the current app we've been building. So the way this works is if I go up here, there are 3 projects, 4 projects really. So there's a client, a server, a shared library, and a web component. For this, we can ignore the client side. That's a CLI way to kind of send pixel information over to SignalR. So if you wanted, instead of having an actual canvas, if you just want to send the pixels over a CLI, that's what the client is for. The server is what's actually delegating all these messages. So SignalR is a client-server communication model. So instead of your clients knowing about every other client that connects to a website or a server or something, instead they just need to know about the server, and the server will keep track of all of that and broadcast those messages back. So in this case, a client will say, hey, I changed this pixel on our canvas. Tell everybody else. And then the server will broadcast that message out to all the clients that it knows. And then those clients will receive that message and act on it. In our case, we don't even do any logic on the client side when we actually act on it. It's only once we receive the message back from the server. The cool thing with that is we don't actually have any difference in the logic between the person who's actually clicking the pixel to write it and the person who is just receiving it and viewing it. There's no actual difference in how showing that is done. And then we have a shared library. This is just for my data models. The useful thing here, Blazor is a .NET app. So that's what we're using for our web component. And this allows us to share our data model between our client, server, and web model, so that we can actually use the same thing everywhere. This is kind of useful for deserialization, so it's all synchronized and we're actually correctly deserializing the right models. So that's why that's separate. And then that way we can just include that into all the projects and then they'll all be in sync. And then the other thing is our web component, which is our Blazor thing. That's mostly what we're going to be working on. The server is done. We've already finished that. We can briefly look at it because it's a very small amount of code to actually set up a SignalR server. So that's that. So what we're going to be mostly looking at is kind of how do we finish off this? Because we don't really have a lot of the actual UI working yet, so we need to kind of do that. So I'm going to jump into our server and do a .NET run. And the way this works, we have to start our server first. And so this will build and run that server for us. And then we can actually run our web component, and that should connect. Or we will get a, that's my bad. I still have the old one running. So we get an error here for the port is already in use. That's because I had the server previously running for the other version. I have 2. So let's redo this. So restarting the server. That one should work. There we go. So that all looks correct. And then we actually end up here. All of our work has ended up in this canvas thing. And the way it currently works is we have these buttons that have numbers in them. And when we click one of those buttons, we're actually going to send a message. You can see the messages down below. Each of those messages goes up to our server and then gets interpreted, and we just increment the number of whatever thing that is. So what we can actually do is create another copy of this. And this one will be behind what's currently updated here. So we can make that just slightly bigger. And we have this one. And so this one is all zeros. There's nothing changed here, whereas this has some actual data in it. But if I click 1 now, you'll see the message comes across on both sides. So both of these clients are receiving the message because the server actually broadcasts those messages out to both people. So that's how that works. Right now, our message is an X and a Y coordinate, which represents where on this grid we are representing. Think of it rows and columns. We're just using X and Y like you would on a graph. And then we also send over a red, green, and blue value for the pixel color to actually represent what color to actually use to represent this thing. Right now, that's unused. That's what we need to actually support in this next little bit. So that's where we're currently at. Let's actually start fixing this and adding some things. So there's a few different ways we can do this. We need a few components to actually make this work. The first one is some way to pick a color. Because we need to create a brush for the player, or for you to use to actually insert colors into this and actually have some sort of selected color to draw with. Because otherwise, how do we know what it is? There's a few different ways we could do this. We could do a text box, and you could input some sort of hex value. I think using just buttons with colors on them makes a little bit more sense. It's a little bit easier to use. And so that's sort of the direction I'm leaning, but we can kind of solve this in any way we'd like. So that's sort of the first thing we're going to do. So I have the other project just for notes, just so that I keep things together. There's a few weird things that I decided to add because it was weird. So we'll do some of those too. An important thing, if we use color here, so input our system.drawing.color. I think that's the right color component. But let's just say color equals color dot something. There's a bunch of different colors here that are pre-programmed for us. The problem with this is these are, I don't think, string values. At least I haven't found a good way to get these into strings. So I've had to manually convert them. There might be a better way to do that. But for me, I've just been, I wrote a series of scripts to do that. Because these are stored as red, green, and blue values as byte values. So the way a color is typically stored is 4 bytes in just like in a 32-bit integer, basically. Except it represents the alpha channel, which is transparency, the red channel, which is red, and then the green and blue channels. And each of those is separately 8 bits. So you have a byte for each of those. So it goes up to from 0 to 255, and that's sort of the color range in each of those colors. So that's a change that we actually need to add here, because I think our pixel model is using floats. So from 0 to 1, ideally, where 1 would be equal to white. That's not really what we want to use, I don't think. There's a few options we could choose. We can either use a hex value, so we can actually use like the hex encoded value for this, which is what is actually going to be needed to actually render this onto the screen. Or we can store the byte value, which I'm just going to represent as ints, like this. So red, green, and blue. We don't need an alpha channel here. Because transparency isn't a thing we're going to work with. And so that will change our data model. We'll need to restart our server after doing this. But that should get everything sort of in line with what we're trying to do. So I'm just going to do that. And then we shouldn't need to touch anything else. That should fix our server. And then I think we might have broken a few other things, but it actually looks fine because we were already casting things from ints. So this is fine. The only difference is now we have ones and we need them to be 255 or a full white value. So that's a slight difference there. Otherwise, those will basically be black. So the way this works is we create a hub connection, which is actually the server that we're connecting to. So we're giving it that connection, and then we're setting up responses to that. So in this case, we have a pixel update that's going to actually respond to something. We need to react to that. So before I get ahead of myself, let's create our brush. So we're going to create a brush color equal to color dot Let's set this to just black, I guess. We can mess with that later. And then the other thing I'm going to do is create a, I guess, IEnumerable set of colors, which will be our brush palette. I forget how to spell. That's probably wrong, but that's okay. I will fix that later. We don't need to worry about spelling right now. So we're just going to create a really quick color list here. There are pre-programmed colors, so we can just do some, let's do white, color.black, and let's do the primary colors, so red, green, and blue. That is not the correct green, but that's okay. That green is actually not the full green. You can see it's like halfway between. Anyway, that's a nit that we don't really need to worry about right now. So that creates a set of 5 colors for us to choose from, and we have our brush palette that we can use. And so what I'd like to do is with Blazor, you can just input code into what you're creating. So this just allows you to sort of input whatever you like into this to actually start defining how things should appear. So we've already done that. We have 4 loops here. We're going to do that again with for each color in our color palette. Where what have I done? That should show up. Just checking my access modifiers, but I shouldn't need to do that, I don't think. Oh, that's because it's not called a color palette. That's my bad. So it's called brush palette because that's what I named it. And so we get these different colors, and we can just iterate over these and create. In this case, I'm just going to create a button, very similar to what we have below here. So we're just going to do a button, and I'm going to style this. We actually have Bootstrap attached to this project, so we can actually add some default styles to this. So it's already suggesting a few of them. I used a button and a button primary. And we'll add some custom styles here. That's one of the interesting things that we can actually do with this. It's just another web project. So you have this entire www root folder over on the right-hand side here. This contains your CSS, your index.html, things like that you might actually be used to with normal projects. It also means that you can access all sorts of other fun things. So that's where we're going to kind of put that. You can even include things like JavaScript in there if you want. So we have this button that's going to actually trigger and launch this. I'm going to actually throw a style on here. And let's just say width 64, height 64, pixels. There we go. Again, I am very much not a front-end developer. So this is not necessarily something that I'm super familiar with, but that's sort of what we're going with. And then I also want to assign a color. So the best practice that I found is to just always save these. We previously ran into an issue when we were doing this, where if you had loops, you would actually run into issues because you would actually loop through the entire thing, and then you'd have deferred clicks. So these on-click methods would use the maximum value every single time, no matter where you clicked, if you tried to reference the value you were iterating over. So what we're doing here is actually just persisting that, and I'm going to do this here as well. So brush selection, I guess, is equal to our color. So that just saves it. And then we're going to assign that to the background of the button. So that's not right. Background color. And we're just going to say and then something. In this case, let's just say brush selection. And I believe that's going to break. But that's totally fine. We'll get to that in just a second. And so we have all of that. And that should actually display some buttons at the top of our screen. So we actually have something to see. This might cause a few issues. I'm not expecting just displaying the brush selection like this to work. It didn't when I previously tried it, but I've also been changing things, so it's possible that it does now. Yeah, that's sort of expected. So we do have 5 buttons now that are bigger than the rest of our other ones, but they're not colored. We tried to set the background, and it didn't work. We might even be able to see what those got assigned to. So if we go and look here, yeah. So this is hard to see. Okay, I can scroll this in, but the color is actually color and then in square brackets white, black, red, green, and blue, which isn't particularly useful as far as the actual color we're doing. So that's probably not what we want. What I've done is just kind of write a really quick script to automatically hex format these. I think there's a better way to do this. I just haven't found it yet. So we're going to kind of slightly hack around this, and we're going to create a function for this. And that's going to be color to string. And so what this is going to do is take a color like we have here and convert it into a hex string that we can use to represent up here to actually draw to. And so we declared that function now, and then we can just throw it down here with a public string color to string. And we'll just throw our color in like this. And then what we want to do is just implement this. And I think, luckily, with this is actually a fairly, I don't want to say straightforward, but you can use some trickery to actually make this work. There's a string formatter that can actually output different things for you. So in this case, we can return a formatted string. We do need the hash sign so that it knows that it's a color. And then the way this works, we can do color, and then it's just red, green, and blue with 2 symbols. So we want X for hexadecimal and 2. And that should format that as a 2-digit hexadecimal string. So that will convert an integer value, which is a red value, into a 2-digit hexadecimal string. So we should get those F values that we expect. And so we can do this again for the green and the blue, like this. Dot blue. And so it's kind of hacky, but that will actually get us into these correct strings. And so if we run this again, I believe I've made that change. Yes. We should actually see the correct background color now, so we can actually see what's going on. And it's kind of a way for us to show integrating all of this together. We're also going to kind of pull a lot of this out, because I would like to customize the strings for this. Apologies for the train. But there we go. So now we have our buttons correctly formatted, so they actually have the background color applied to them. So now we have our red, our green, and our blue, as well as a black and a white. So now what I'd like to do is pull out some of this information. So we have this width and this height that we added here. I don't really want that just to be sitting around inside of this button with a specific style for this. That's not really what I'm trying to do. Instead, let's go into our CSS data, and then we have app.css, and we can actually just change it here. So we can actually just introduce something inside of this for our pixel or brush selection, I guess. I need a period there. Oops. All right. And there we go. So let's just add a width. There we go. 64. And a height of 64. And that's that. This doesn't work. Well, it does work, but it doesn't work. It's weird. The issue we have is that these style sheets are actually saved by your browser. And so your browser is actually going to cache these. So we deleted the width and the height from this component. And so if we restart this, we'd expect it to look the same as what we had. But that might not necessarily be the case when you try this. At least it's the case that I've run into where things just don't quite work out. Because if we go into our canvas, we get this. There's nothing in our buttons. And so it doesn't work. And even if we actually go and look at this, we can see, let me find that component. We can see it's assigned the brush selection class. But if I actually go into my sources here, I can browse to whatever that I'm looking for. So in this case, we're looking in our app.css, and it's not there. We don't actually have those changes we made. The issue is those changes were made, but this version of this app.css is actually cached. So we aren't seeing those changes. The way I found to get around this is just creating in private browsers. It's slightly inconvenient, unfortunately. But this, because restarting an in private browser clears that browsing data, you actually don't run into this issue and you get the correct thing. So now our actual updates are still there. And we can go in and double check just to make sure. So if I actually go and inspect the source here, we don't really need to go to actually look at that. We can just go and look at our CSS. And now we actually have the changes that we made. So they're there, they just might not show up. And this confused me for a while. Anyway, if you're running into that issue where you think you've made a change and it isn't showing up, that might be something to look into. This also applies to other changes in that web root directory. So if, for example, you want to maybe swap something in instead of Bootstrap as your style sheet library, if you want some other sort of style, you can just come into here and swap out Bootstrap, for example. But if you do that, the other changes might be cached. So you might actually not necessarily see those changes right away. So there's something to be aware of. While we're here, this isn't something that we're actually using, but it's something I'm going to call out quickly. So we can actually link, let's say we import a new project. There is a special content directory, which you can actually use to reference other projects. So if you have gone and imported something, let's go into our dependencies and add a package. So in this case, let's say there are color pickers out there. So one of the ones that I was considering using for this project and ended up not using, let's see, those are for other things. Let's do Blazor color picker. There we go. So for example, if you wanted to use this project comes with its own CSS library. And so if you wanted to actually do this, you can actually reference those CSS components and JavaScript components directly from your own project by using this content link. So that'd be like Blazor color picker, which is the name of the library that you'd be importing. And then that gets you into that project's web root folder. So if you wanted if we wanted to reference our own thing, it would be like css/app.css. And that would actually let you access whatever content that is, which is super cool. It means you can kind of import all sorts of fun things just as NuGet packages and then get those JavaScript and CSS components directly in. But it's interesting. So yeah, just calling that out because I had to learn it. So there we go. So let's actually get colors working. So the other thing that I kind of want to add here is a pixel. I just want to make sure I get the style sheet right for this. So let's add a pixel with a width of, say, 32. And I'm using just explicit pixel heights and widths, just because that's, I guess, what made sense at the time. And then I'm also reducing the border around these buttons for the pixels. So we're going to do a 1 pixel solid black border. And then the other thing, I think that's it. So that will create our buttons for us. And so if we apply that to our pixels, let's I guess let's do that. So there's a few things going on. First, we have our color picker, which is up top. By clicking one of those, we're going to select a color. We aren't doing that yet. And then we also have this, which updates our canvas position. So what we want that new function to do is take the selected color and apply it at that pixel position. So we want to see what's currently there. So let's go and grab that style background color and assign that to color to string. We're just going to look up the color at this position. So canvas, X, and Y. This also brings up an issue. There's actually a bug in my code, which I don't know. I don't know if any of you saw this, but we did X and then Y when we're doing this for loop. That actually isn't correct. The way this is actually working is inverted from that, because this is our lines. The X is our lines, and then or our rows, and then the Y version is our columns, which is the opposite of what you would probably expect when thinking about this. So the top right is actually Y16 instead of Y0. So we need to switch these just to make everything correct. Just so that it's actually in line with sort of how I'm thinking. Otherwise, we'll get weird errors later. Because if you actually try to send something with proper XY pixels, it's actually going to be tilted 90 degrees, and we don't want that. So here we go. Why doesn't it like this? Color to string. So the problem with this is our canvas is currently storing integers because that's what we were drawing. We're going to pull that out, and we're going to actually just store our data models there. There shouldn't be an issue with actually just storing them like that. So that's what I'm doing. So let's take our pixel data model and throw that in there. So our pixel data model is now our canvas. Instead of integers with that increment when you do this, our canvas is now going to store this. Yes. So is this Blazor? Yes. This is a Blazor website. Right now we're just editing code. We are building a interactive canvas. So you can actually go and draw pixels on the screen. And then those get sent over a SignalR component to a server, which then comes down to all the other Blazor websites, which can then update them. So everybody who's looking at the page will see and be able to update everybody else's drawing. So it's a slightly limited version because we have five colors. But there we go. So our pixel data model is right here. And yeah, a few things broke because I changed that. First off, we can't just assign our canvas like this. Instead, I'm just going to replace the increment and just directly assign the data model to where that is. So there we go. Yeah, budget our place. Yeah, basically. I'm hoping that this is something that people will be able to use in some of our reactor spaces, which are sort of community spaces that you can kind of come into to host events or come to events, either from the community or Microsoft, and kind of meet some of us. And hopefully learn some cool things. But trying to get some cool tech examples in there. And this seemed like a fun one where you could actually potentially like send messages between the spaces. And a lot of the SignalR demos that I've seen are all chat apps. They're just sending messages back and forth, and chat makes a lot of sense. So we're trying to do something a little bit different here. If you want to make a chat app, all of the same examples will work. You just have to change out red, green, and blue with a string for your message. So there we go. And then, yeah, I think that's all the changes we needed to make. This doesn't look right. We need to actually create a color from this. Oh, I know what's going on. I was doing all sorts of weird things. So this is currently writing out a version of was writing out an integer. We need to change this to a string or into a color, and then change that into a string. So to do that, we're going to create a new color. So from ARGB, which is alpha, red, green, blue, we're going to ignore the alpha channel. Again, our example does not need that. If you need transparency, don't ignore the alpha channel. And so we're just going to grab our canvas x and y dot green and canvas x and y dot blue. So there we go. So this will actually allow us to grab this design and send this over. And then there we go. So what this should do, if I have done this correctly, is replace the background color of each of the buttons in this list with the color that is assigned to them from the thing. I know this is a lot of code to do at once without any examples. I'm sorry for that. Unfortunately, because we're sending these messages up, we kind of need to do it all before we can show it working. That's sort of why I had the demo at the beginning. Just so we kind of know where we're going. The other thing I'm going to do is remove that. So that removes the canvas reference, which was a number. It would have been the serialized component of the X, Y, and color values, which would have been really long and made the buttons really confusing. So we're getting rid of that. And then the final thing we need to do is fix this. Actually, there's two things, sorry. So what we need to do here is grab our color. So we have our brush color dot red, green, and blue. We need to grab that and send that over as a data model. So this is the message that we're actually sending up to SignalR. We're saying, hey, update this pixel at this X and Y position coming from the button we clicked with this current color that we've selected. So whichever palette color you've selected, or the default if you have it, which is black. And then that will get sent over to that update that pixel. The server will then broadcast that back. This is the on button click thing. So there's no logic here to update our pixels. So the advantage of doing it this way is there's no risk of desync, which can get a little bit weird. For example, if you mark it on your client and then the server maybe rejects it, or something else happens where the server doesn't receive that message, then you're no longer in sync, and you may think that you actually made an update that didn't actually happen. So by doing it this way, there is some lag that gets introduced because of this, because the message has to go in a full circle to get back to you before any update happens. But because of that, it makes our logic a little bit simpler. So that's sort of why I've chosen this. Depending on what your needs are, you might want to introduce something a little bit more complicated so that I can actually handle those events where things get out of sync and it needs to resolve that difference. So there we go. There's our pixel update. That will send that up. And the final thing, we should initialize our list. So that's what we're going to do now is for int y. This is the fun part because we get to write 2 loops. There we go. And then let's do the same thing for our x value. So this is just iterating over that grid. So x and y. Again, we're doing Y first because Y is our rows and X is our columns. And so with this, I'm just going to initialize all the colors in this canvas. So X, Y equals a new pixel data model of X and Y. And then we need a red, green, and blue value. So 255 will get us white. And that should, hopefully, we need a new there. There we go. Cool. All right. I did that a little bit fast, but that should be everything we need to actually get this working. And I say should because it probably isn't going to work. But we'll see why in just a second. It's mostly an issue with our buttons. There's no style attached to them, so our buttons should be very small. We already kind of saw that with the original brush palette. We didn't have any style sheets assigned to them, so they got very small. The same thing is going to happen here, where we get this. Again, this is the cached version of that style sheet, so both of them are wrong. But we don't actually even have a class assigned to these, but it should work. So it's super small, but if this actually works, I should be able to start sending updates like this. And so we can actually start drawing on our canvas. Downside, I haven't actually hooked it up to select the color yet. That was my mistake. Oops. So that needs to happen because I overlooked that. And then we also need to apply the style sheet. So those are the two steps to kind of bring this all together and get this all working. And then I can kind of step back and kind of walk you through how the entire project works. So we need to take this. If you're, we've done this a little bit, but Blazor allows you to kind of inject C# code directly into otherwise what looks like HTML. So in this case, we want to add an on click, which is going to be our update. We actually want a function here, so I'm going to escape that as well and insert a little bit more. So we'll get some function triggered off of this on click with mouse events coming in. And so if we want to invoke a function and pass in some things, in this case, the brush selection color, we need to do something. So this will be update brush. We're just going to change that to our brush selection like this. This function doesn't exist. So let's go and create that. So we can just scroll down here. Inside of code blocks, you can just insert code. So this is just normal C# code. Again, you can add NuGet references, whatever you want. So there's our update brush. Do a void like this and add in color. We want our brush color to be equal to our brush. And so this will just update this. I tend to put these in functions. There might be ways to do this without using functions. By using functions, if you ever need to expand this, it still works. And you don't need to make too many changes. Otherwise, if you have explicit logic inside of these functions, I found that can get really complicated, especially as maintenance needs to happen, or you need to test it, or other things need to happen. It becomes harder. So that's that design choice. And so there we go. That should update our color. And then the other thing we needed to do is update the style. So there's a style here that's choosing the background, but we also want to assign a class for our pixel. So we already created this. This is part of our app CSS. That's this. So there's no margin or padding, and then we're just making them a fixed size. So fixed X and Y, width or height and width. So they should be square and kind of just enlarged pixels. And then we have a reduced border from the normal buttons, just so that you can actually more clearly see whatever art you decide to draw. So let's run this, and now it should hopefully work if I've done everything right. So hopefully what we will see This version is still going to be broken because we still have the cached version of our canvas. It looks like this, but we should now be able to draw with like green, and you can actually see we're no longer sending over black. Because these aren't all zeros, we're sending over something else. Now we can do red, etc. So let's open up a new in private window. That's not going to work. Let's grab this. And create this page. So this will open that up. There we go. I need to add a line break in there because that's a little bit weird. But there we go. We have our way of doing canvases. Bootstrap inserts custom line separator or line heights. So we can actually, we'd have to remove these if we wanted to. But now we have a thing we can actually draw on. So we can create that smiley face from the beginning of this stream if we want to, I think. Like that. And there we go. And so all of those updates, all of those colors were sent up through a SignalR server and sent back down saying, update this pixel. And if I want, I can even, I think I can just do this. Go. Create another one. Again, we don't save state. So the server doesn't know what the state is. It doesn't actually do that. All the server is doing is sending these messages. It's sort of serving as a relay and taking messages from clients and sending them to all the other clients. And so when we launch a new client, we don't get any updates. But let's say I wanted to draw something else. So let's just draw the three primary colors, doing something weird. I don't really know what. And both of them will see that update. And this works on either client. So if I go back here and maybe outline this in black, this client also sees those updates. And these are both running on my machine. They're both local. But this is not just a local thing. This can work across servers or across networks. As long as they're connected to the same hub, they will be able to receive those messages and be able to actually respond to them. And so that's sort of the end state. If we do want to remove this final thing and kind of fix up some of this styling, let's go and, I guess, do that. So the way to do that is to go into our canvas. And I guess, again, HTML is, or front-end stuff is definitely not my main skill. It's not something that I'm very good at. So there might be better ways to do some of the things that I'm doing. But this is sort of how I found to do it, and hopefully kind of gets you started in thinking about ways you can maybe use SignalR or Blazor if that's something you want. I've actually been really enjoying Blazor. It's super cool. So if we want, there's a root, and we can just remove. This is not probably the way to solve this, but this will completely remove the bootstrap line height from everything, which means text will also be affected. So we want actually, our text that we're currently drawing is going to break, but this will fix our buttons. So there's some interesting trade-offs here. I kind of like the solution because of it, and probably not doing a global fix like that is probably not the best choice for most reasons, but there you go. You can see we did fix the break, moved the thing down. And so if we go into a new in private thing, and let's do these again. There we go. So we now have our two canvases, and now there's no breaks there. The downside is we removed line breaks. There's no line height at all between text. So we used to have a text that would show the updates that got sent over. Those are currently now overlaid on top of one another, which you can see ends up looking great. So that's a side effect of changing it in this specific way, which might make it less of a good choice. But that gets that to that point. And so, yeah, we have a series of colors that we can choose. I've picked 5 in this case just for this demo, just because watching me pick and type a bunch of color names didn't seem like a cool stream. So there's 5 here. But if we wanted to add more, it's just an enumerable list. Because we're just iterating over these, we can just pick more of them and it will work. So that's that. What else? If you do want to actually try this, I will be pushing this up to GitHub probably tomorrow, a full version of this with instructions for how to run it and get started and set up, and probably with some of this extra stuff kind of trimmed off, just so there's less noise. So if that's something that you're interested in, check it out. There will also probably be a few extra, I don't really know what exactly, but streams or something else to kind of show finishing this. Because right now we have something that works. There are certain things like authorization that would be nice to have so that you can prevent somebody from just coming in and overwriting the entire thing with a bot or something like that, which currently is totally possible. Anybody could come in and do anything if they had access to the server. And so that might not be what we want, especially if you're trying to build like a chat or messaging app, and you probably don't want other people reading your messages. So in order to do that, we need some sort of authorization or auth solution, which we don't have. The other thing we need is storage. Ideally, if you're going to draw something cool, it doesn't get deleted as soon as you refresh the page. And that's exactly what happens here. So if I go and click refresh, it's gone. And that isn't great. So we'll need some sort of solution to actually solve that. There's a few different choices we have there for actually how to do that. And we can either actually send the entire thing, so every single message, instead of just sending the current pixel that you're updating, we could actually send the entire state and just say, this is the new appearance of everything. And that gets rid of the issue. And then the server just needs to track it instead of clients having to worry about it. The downside is then your messages become much larger, especially this is a 16 by 16 grid. If we wanted to make this a larger canvas, that increases the size of everything we're sending potentially by quite a bit. And it would eventually limit us just because we can't send megabytes of data as a single update every single time we want to change a pixel. So there's some options there. We also need more colors. So anyway, quickly in the next like 5 minutes, I'm going to kind of run through how all of this actually works. So if you're interested and maybe missed the first 2 sessions that we did kind of introducing this, hopefully that'll get you started. Again, if you do want to catch these, or maybe you missed the first part of this one, those all end up on the Reactor YouTube channel. So you can go and check those out. The first 2 should already be there for viewing. This one will probably end up there in a few days. So I'm just going to stop this, and then let's look at the code quick. So the I guess coolest part is the server. So the way this works is this is just an ASP.NET site. So just like you would create a normal REST website or something, you can create a SignalR hub. So the difference we have is we've actually added this SignalR service. There is, because of the way I've designed my solution, where you have a completely separate server and a client where they can run in completely different places. We had to add some CORS headers, but you won't necessarily need that, especially if you followed some of the getting started with SignalR tutorials. Those have solutions that kind of integrate both the client and server, so they share the same port. Then you don't run into CORS. So that adds SignalR as a service. And then the next thing we do is map a hub. So the hubs are what we're actually talking to, and all they are is just a list of functions that you can call. SignalR works by sending clients, having clients send servers messages, and those servers are able to send clients messages. So there's a client server communication network. The way these work is with RPCs, or remote procedure calls. So clients can call any of these public functions in your hubs, which means a client can call pixel update, which is exactly what happens. If we look at Canvas, which is that page that we were just updating, this actually has a reaction to pixel update, which is coming in, but also it's invoking pixel update. And so what this is doing is saying, run this function with this data. So it's just a typed invocation of a remote function. So all this is doing is saying pixel update with this specific parameter, run this code on the server. And so it's a strongly typed thing. So both of them have to have a pixel data model, and that will be serialized and then deserialized automatically for you. And then that gets pumped into here, which can get processed. The server and the hub track the clients that are connected. And so you can kind of filter those if you want to. In our case, we just want to send the message back to every single client. And we're basically just reduplicating it. You do not need to use the same name. I did just because it seemed like a good choice. I might change this actually, just because it might be a little bit misleading. This name doesn't need to be the same. So this name right here is the method on the clients to invoke, which is being triggered by that on function. So in that case, that client's invocation is mapping to this hub reaction. So in this case, it maps to the same name, but again, they don't need to be the same, and it's another typed response. And again, receiving the pixel data model because it's just a loop. Basically, information comes through here, loops up through the server, and comes back into this response. And then we just update that and then update our state. And so that's sort of how all of this is working. And then to connect to it, we are just connecting like we normally would to a normal REST endpoint. So we give it a endpoint with the location of our hub. So in this case, we have where our server is hosted. This should be displayed for you when you run your server. So we're connecting here. So just copy this, paste it here, and then add on your hub connection. So Pixel Party is sort of the name of our app, and that is mapped to this hub mapping that we've done. So if you were normally mapping, say, REST endpoints or something, you would have those. In this case, a single hub can contain a number of remote procedure calls that you can invoke on it. And so you just need to connect to the hub, and then everything else will be kind of handled for you. And so that's what's going on. And so you just have to implement this hub, map it, and add the SignalR service. You might need to add cores if you want to, but that shouldn't necessarily be needed. And then what else? I think that's mostly everything we're doing, because there isn't anything special going on elsewhere in the app. It's all just a normal Blazor app. We just created a new Blazor app. And then most of the implementation ended up inside of this Canvas project. And a lot of that is actually just handling the logic of the app we created. And so to actually get everything working, to get everything connecting, you create the hub, build the connection, set up the callbacks for how to respond to that, and then start the connection, and then you're done. So anyway, that's SignalR and building this interactive web canvas. I hope you liked it. If so, we do have a survey, and if you didn't like it, also we have a survey. That it's sort of our way of judging: is this a good thing? Did this work, or should we change something in the next time we run a series? So if this is something you enjoyed, or something that you think we should change the next time I talk about SignalR, or or maybe consider just talking about something else, let us know. And thanks, everyone. Hopefully this was fun. A fun way to learn SignalR.
Thank you so much, Sam. Thanks everyone for joining us again. And as Sam mentioned, we have this AKA link for our survey. Please, if you have a couple of minutes, go to this link and use the event code 16162. Would really love to know your feedback. And thanks again for joining. Thank you, Sam.
Thanks, everyone.